Hello, everybody. This week we are focusing specifically on unit rates and solving problems involving unit rates. This is something that we introduced in Unit 2. We talked about rates and we started looking at unit rates last week. So a unit rate is a rate per one. We looked at some examples in the Engage section. You added them to the Padlet this week. And we'll look at some more examples right now today. For example, 12 people share 2 pies equally. So that isn't per one, that's actually 12 people sharing 2 pies. So 1 unit rate is 6 people per 1 pie. There are 6 people per 1 pie because 12 divided by 2 is 6. And the other unit rate that you can get from this same information is 1/6 of a pie per person. And you get this by going the other way around. 2 divided by 12 equals 1/6. They're both unit rates. Now, you'd use these for completely different purposes, like depending on what it was you're trying to work out from the problem. So every piece of information to do with unit rates actually has 2 unit rates, depending on which way around you divide. So 6 people per pie, that could be important information. Or we want to know how much pie each person has, we would get 1/6 of a pie per person. Both of these are unit rates from the same piece of information. So a unit rate tells us how much of one quantity for one of the other quantity. And each of these is useful depending on which information. So we have an example here involving blueberries and price. If we want to find out how much 8 pounds of blueberries will cost, it will help to know how much 1 pound costs. So we're told that 1 pound is equal to 5/2 or $2.50. So therefore we could multiply by 8. So we could do 8 multiplied by 5/2. So that's our multiplier here, because it's our unit rate. And that could be useful in some situations. But another way we could do this is to find out how many pounds we can buy for $10. So it helps then to know how many pounds we can buy for $1. And this is the other way around. So in this instance, our multiplier is 2/5. So 5/2, the reciprocal, which is a word that we haven't really introduced and not one you need to worry about, but it's one I'm going to use. It's kind of like it's flipped over. So the opposite of this is 2/5. You're multiplying by 2/5 every time. So this information that you need and which unit rate you used completely depends on what you're being asked. Let's look at some examples. This table shows different amounts of apples selling at the same rate, which means all of the ratios in the table are equivalent. And in each case, we can find the unit price in dollars per pound by dividing the price by the number of pounds. So for example, we have apples here listed for 8 and 20, and we have the respective price in dollars next to them. So we can find the unit price by dividing, I'll show this in just a second, by dividing the price by the number of apples. So 10 divided by 4 is equals to 2.5, or $2.50. We can do the same thing here. 20 divided by 8, it's going to give us $2.50. What do we think is going to happen here? 50 divided by 20, $2.50. It's not a coincidence that it's the same amounts. That's because it's the unit price. So the unit price is always the same, whether we buy 4 pounds of apples for $10 or 8 pounds of apples for $20, the apples cost $2.50 per pound. So that's our unit price here. We can also find the number of pounds of apples we can buy for $1 by dividing the other way around. So for example, this table looks very similar to the previous one, except instead of dividing 10 by 4, we're dividing 4 by 10, and we're getting 0.4 every time. We can get 0.4 pounds for $1. So again, it would depend what we were asked to do for this question. The number of pounds we can buy for $1 is the same either way, though. So when 2 ratios are equivalent, the 2 unit rates will always be equal. So both of these were unit rates. I'll go back to that other page as well. See how we divided a different way around. 10 divided by 4 gives us the $2.50, but it's important to note that this is dollars per pound, whereas this is pounds per dollar. Sometimes we can find and use more than one unit rate to solve a problem. So I'd like us to take a look at this problem. A grocery store is having a sale on shredded cheese. A small bag that holds 8 ounces is sold for $2. Then we have information about a large bag that holds 2 kilograms is sold for $16. How do you know which is a better deal? We have a lot of information here. Well, we can compare dollars per kilogram, or we can compare ounces per dollar. There's a couple of things we're going to do here. We can first of all see that the large bag, this large bag, must cost $8 per kilogram. So 16 divided by 2, so that's the amount, dollars divided by 2, gives us $8 per kilogram. The small bag holds a half a pound of cheese. Well, there are 16 ounces in a pound, so half a pound. So hang on, the small bag holds half a pound of cheese because there's 16 ounces a pound, and 8 divided by 16 is a half. So there you go. It's half a pound of cheese. Excuse me, I was just rereading that. And the small bag therefore costs $4 per pound. So we have these rates right here. And the large bag is a better deal because it costs less money for the same amount of cheese. So we have to figure out here that there are 2.2 pounds in a kilogram. So I think you have this information listed somewhere in this unit. I'll find out where and I'll share that with you. Usually it's in your planner as well that we have all of this information. But if not, I'll share a different list with you. There are 2.2 pounds in a kilogram. So we can say that the large bag is a better deal because it costs less money for the same amount of cheese. We could also compare ounces per dollar. So this is the other way around. And what we can say is that with a small bag, we get 4 ounces per dollar because 8 divided by 2 is 4. That's 4 ounces per dollar. And then looking at the large bag, it holds 2,000 grams of cheese, and there's 1,000 grams in 1 kilogram. So that's 2,000 divided by 16, which is 125. And you are allowed to calculate it for basically the whole of this unit. And there are about 28.35 grams in 1 ounce. So therefore, we need that information too. 125 divided by 28.35 is around about 4.4. That's about 4.4 ounces per dollar. So this is the tricky bit, the get into the conversions. And we're not really going to worry about that too much this week. I'll make sure that we have like a cheat sheet of different conversions, and we will talk about that. But the main thing we're focusing on is how you do the division, how the order in which you divide changes depending on whether you're looking at, for example, dollars per kilogram or ounces per dollar. So in this instance, we have 4 ounces per dollar or 4.4 ounces per dollar. So you get more with this one. So the large bag is a better deal because you get more cheese for the same amount of money. So these are problems that we're going to work on in this unit.